Thank you very much, and very good evening, everyone. I know it's slightly late in the evening, so I hope with this August panel that we have today, we can make it worth your while to discuss this very important topic of unlocking the next wave of energy solutions in electric vehicles. I think when we talk of battery solutions, there's a lot of talk about batteries in all sorts of directions. First and foremost being this whole raw material conundrum. I think just today morning some statistics had come out that we imported close to about $2.8 billion worth of lithium only last year, and about 95% of it coming just from Hong Kong and China. And this has almost doubled over the last 1 year. At the same time, there's also talk about sustainability in the supply chain, on its, especially in the mines around ecological degradation, as well as the human conditions of working there, which are being talked about. Coupled with that is the whole material shortage thing. There's enough in the Earth's crust, but not maybe enough in terms of mines, which is again becoming a topic of interest. Then there is Indian climatic conditions and usage conditions, and how the thermal effects happen on batteries here, which is again something which is being talked about a lot. Added to that is this constant endeavor of packing in more charge and less space, less weight, along with also making these batteries get charged, discharged at higher rates. So all those innovations are also being talked about. And finally, and very importantly, how do we also keep recycling these batteries so that we don't have to go back again and again to the Earth's crust to dig in more, and we keep on using all of this. So I think to discuss on many of these aspects and what the future holds in this area, I think we have a very august group of panelists with me. And to begin the discussion, I would straight away go over to you, Mr. Ramashankar Pandey. Starting off with this whole thing around SDG goals and batteries, and there are talks, and probably rightly so, about what happens to the environment around a mine. There is also a lot of talk about human rights in these mines, especially in places like Congo, etc. Given that Tata Green Batteries has established itself as a very strong player in this space, and also a very responsible player in terms of managing the SDGs along the value chain. So what are some of the learnings from there that could be applied to lithium-ion batteries value chain as well?
Thank you so much. I think, as you said, that Tata Green Batteries has been over some time here in India, with GS Yuasa as its partner or the co-owner. Actually, the name Green itself, imagine roughly 16, 17 years back, the name was put Green, which actually tells you that the fundamental of the philosophy of the Tata Group on this company at least was around SDG. And when you look at battery as a category, it has a huge implication. And also more so now, it's like roti kapra makan, you need power as the everybody needs power, and power has battery as an integral, and not only for the auto, but even otherwise. Power generation or power uses, batteries are everywhere. We are sitting here around us, and it's not only lithium-ion is in automotive only, but across in industrial uses, in data centers. And I'm pretty new to the battery industry. I'm just now 5 months old. At Hela, I was long years, and I think SDG remains for the industry now on a top target. You can clearly see in all boards this social development goals, what United Nations have put. I could relate to that now coming to Tata is on a very high level. And here, the biggest thing is the circularity of this, because now we are in a big hype and we are going gung-ho everywhere. But what happens now when this whole circle going to close or end? Unfortunately, or I'll say, luckily, whatever we have in India, the whole circular economy is running on itself, on its own, because typical kabari wala, what the whole, the value of the lead or lithium or all this raw material is very, very high. And because of that, there is an industrial pull, and there are mediators. And these mediators have come up just like the way the first EV came in our country, like these auto rickshaws in Delhi and Bihar and UP, it came on its own. Similarly, here also what's happening, and that's a cause of concern also from our side, that without any designed approach of the industry, this is functioning. And let's look at even in the lead acid. I think lithium-ion circularity will come, but let's learn from even the lead acid, because it's part of us. And today what happens in the industry, you can see few players on a very strong consolidated industry. Tata Green has been pretty long time, but still I will say it's remain a consolidated industry, not very democratically wide choice to the market, under which we see a lot of mediators and the smelters. I happen to actually visit a lot of smelters, how they actually extract, very crude process, and the business case is not there to comply SDG, to tell you very frankly. I think it will be disheartening to all of us, but that's a fact. And I personally went to many smelters to find which is the best guy. Can we actually find something where we can really put Tata Green Battery and then we support and approve and authorize? It was very difficult. Then we talked to a few smelters, can we organize this industry? Can we actually talk about, and I think there is a fact and figure which, there's an NGO called Pure Earth, and I got in touch with them to find out what the statistics is. Roughly more than 23 crore child actually today is lead poison. So you can imagine that that's the current, we saw that Mayapuri, how the radioactive material went and reached. I think similar situation exists. If we as an industry cannot do that, it's going to be difficult. So my submission here in this forum will be, it's great to meet like this. There is a challenge, and there's a very big challenge. One company cannot do. As far as vision of the company, Tata Green Battery want to do, we are trying to create a marketplace, to tell you, maybe next month it will be launched. A marketplace where every place where the battery is coming back, we want to give it a geo code with a Q code where the whole supply chain is then tracked. And we want to give it to the customer when and where and how it has been disposed and extracted. This is a dream, to tell you very frankly. I started working on this 3 months back. There is a lot of complication, especially the big mafias, the big middlemen. They are the one who wants to hold on, and their business case is very thin. At 50 paisa, at 1 rupee, they want to circulate the whole lot. The whole hazardous supply chain is in shambles. And I'm really worried, to tell you very frankly, that the way now batteries are everywhere, we need to start something, either at ACMA or whatever association we have, with SIAM put together. Something needs to be seriously done. Today, the vision is there. Battery manufacturing is in our control. There we are not only complying, but we are going overboard. If you come to our factory, you will see we have a laundry inside. We have, every worker comes, he has to take bath, he has to have his new dress every day, so that nothing goes back to the society. Now, this is in manufacturing. That's why this company was called Tata Green. There is a fish pond where every drop of water which comes after treatment, zero liquid discharge, all this can be done within our boundaries. But outside the boundaries, the ecosystem, we are just one player. And that's why forum like this is very important. Can we come together? I can tell you my dream that I've started with this marketplace. More people will come on that. That will be great. And it starts, currently the volume is high on lithium in the lead acid, and it's going to be now on all the chemistry. Whatever chemistry of battery is coming, we need to have answer to this. With this, I think my opening remarks go forward. Thank you.
Thank you. Thank you, Mr. Pandey, also for laying bare the situation right now. And as you rightly said, it's your dream. I think dreams are the seeds from which beautiful tomorrows grow. So definitely, I think that could be turned into a reality if the industry comes to it. So thank you for that. Moving across to you, Mr. Bala. So they say sodium ion may be the solution to many of these ills, which lithium ions has. So what has been your experience, and what do you see are the challenges to make sodium ion penetrate the space, which, whether it is BESS, whether it's EVs, is almost 95, 98% dominated by lithium ion chemistries today?
Any new technology which comes into existence will need its own time to grow. So sodium already has an advantage of almost 3 decades ahead of sodium ion. Sodium ion batteries started at the same time as lithium ion because lithium and sodium are the same elements next to each other in the logarithmic table. Okay. So both share the same properties. Okay. The advantage of sodium is very abundant, 4th abundant material in the world. It is easily available. And sodium battery has a lot of things what lithium doesn't have. One, in some sense, nickel, manganese, cobalt, lithium, nickel, manganese, cobalt, because all the batteries are named after their cathode chemistry. NMC is simply called. NMC, I call always as a controlled bomb. Okay, it's really like if you shot it for whatever reason, it will act as a bomb. Each one of the cells everywhere. That's number one. Number two, it has like, temperature dependency is an issue. If the temperature of the battery varies over 7 degrees in a span of 10 seconds, 7 degrees in a span of 10 seconds, the battery will quickly go into what we call thermal runaway. That means itself activates to react and react faster, continuously react faster. When it reacts, it increases temperature. All of this happens within 20 seconds to the level where the battery temperature comes close to 200 degrees centigrades. Okay, that is like quite a high. And third one, the materials which are used in NMC, especially the additives. The additives are alcoholic based. Alcoholic based additives, however you do, it will combust. It will burn. So third, you cannot store lithium chemistry battery except LTO. LTO stands for lithium titanate oxide. Except LTO, rest of the lithium chemistry batteries cannot be stored more than 40 degrees centigrade for a period of time. And most of the lithium chemistries cannot be operated above 50 degrees centigrade. These are all the issues. And I'm not talking about the environmental issues. Having cobalt, like cobalt is like, it's almost told like, it is the another slavery industry extract. So we don't talk about like, cobalt, we don't talk about lithium, nickel. So if you take all this out, these are the issues of like, lithium. And many countries don't have a lithium, but every country in the world has sodium, enough sodium, okay? So there are a lot of initially, because it's like this. 100 years ago, people talk AC is better. Today we are coming back and saying DC is better. The same way, like 30 years ago, people said lithium is better. Now we are coming back and tell sodium is better, okay? I'm one of the proponents. So, and the reason behind that is like one is abundance, second is like safety, okay? But you can short a sodium ion cell, fully short. It won't burn. It won't like, become a bomb. That's the first thing. Second one, sodium ion cell you can store at 60 degrees centigrade for a few months and get and use, you will not lose any capacity. Okay. Third one, even if you cut a sodium ion battery while it is working, it will not cause any distractions, which is not possible with LTO you can do, LFP and NMC you cannot do that. Basically what means, if you are having a vehicle, you met with an accident, so what will happen is you will have like impact. So that means battery will be deformed. When it's deformed, it has to be safe. That kind of property doesn't exist in sodium, okay? And there was an issue a few years ago, like I started working on 2019 on sodium ion chemistry. At 2019, there was an issue of like, what is the density we had. It used to be 90 to 95 watt-hour per kg, okay? Then what happened in the last 4 years? First, starting with cattle, then with Reliance, with the big investments and all. There are a lot of interest, a lot of money poured into sodium technology. Now sodium has come to a level, it's in between lithium ferrite phosphate and NMC capacity. It'll roughly around like, it's hanging around 150 watt-hour per kg, which is really acceptable level. And the third one is the price of sodium ion is almost close to lead acid. This makes it quite attractive. So these changes has made sodium as one of the viable options. But given that, what do you expect the next 10 years? What is going to be the business for storage, energy storage? 3 factors will drive. First one, decarbonization. That means renewable power. Whenever you have renewable power, you tend to get a lot of batteries. The next one is the electrification. That is moving anything from electric to electric, which may be fossil fuel, it may be something else. So that is going to drive additional thing. The electrification also will create new applications. The same way what like steam engine has created from horses, the power, and then like, from steam engine, internal combustion engine, that power will be there. Third one, the important element is like decentralized DC power, because all the applications will move away from AC to DC. So the DC power, decentralized DC power, will continue to grow the energy storage industry. So if you look at all these three trends and three factors, next decade, our energy, whatever we have, energy storage devices, whatever we created till today, will multiply by 1 order magnitude or more in the next 10 years. So given that, how we are going to meet? No one technology is going to meet it at all. All the technology, at least for the next decade, will coexist to meet the rapid electrification demand or decarbonization demand or digital DC demands. Okay, but very immaterial. Today also, like, people like, I don't think everybody said lead acid will die next year. Lead acid is not going to die for next 10 years. As much as I'm a sodium guy, equally I can vouch and tell lead acid is not going to die for the next decade. If he says he is lying to you, doesn't matter. This is true. Okay, and also, like some sense, it is smart for the government and the rest of the people to support lead acid as much as possible, because coexistence is necessity. Energy, multi-energy storage and multi-energy power devices is a necessity for the world. Okay, it can range from hydrogen to all the way back to, like, your lead acid battery. In between, everything is possible. So given that, sodium is one of the technology. Maybe a decade later when we sit here again, maybe it has overtaken, like, lithium, or like, totally replaced lithium. That it may take its own time.
Sure. Thank you. Thank you for that, and especially laying out the factors, the advantages, and how you see, just like we talk of technology agnostic powertrain roadmap, you're also talking about technology agnostic battery roadmap for the future. Thank you. So I think at this juncture, since you talked about new chemistries, new safety features, tests, etc., I think it's right to take the conversation to you, ma'am. With the ARAI certifying anything and everything that's getting onto the road. How are you coping up with these new technologies coming in, some of which may not need some of the tests that, say, a lithium-ion needs, for example, what Mr. Bala was saying, and some newer tests may also be needed. So there is a lot of innovation happening in this field, and I think the testing agencies probably need to be a step ahead, because you need to test it before it's even put out in the road. So how is ARAI preparing that roadmap so that all manufacturers of technologies can work alongside you?
A great question, I believe. What I believe personally, as so said, it is a technology agnostic energy roadmap today, what we are talking about for batteries. So we are talking about lead acid, we are talking about lithium-ion by itself with multiple variants. We are talking about sodium-ion, myself working with at least a couple of sodium-ion companies. We are working with zinc gel, we are working with zinc air. So technology-wise, where we are, and then solid state and looking and so forth. So when it comes to our testing and certification, see, they go hand in hand, but they still vary. Certification always talks about a minimum quality gates it should pass so that it becomes comparable in the field. But when it comes to validation of any part for that matter, it is much more than the certification that we look into. We look into its completely a full test matrix which has to look into. It can be environmental extremes, it can be a road condition extremes, it can be a safety extremes for that matter. And when it comes to actually a testing and validation, it is very important that we understand the technology to derive design of experiments and design test cases for it. And that is where the strength of any organization should be. Maybe the equipment and the boundary cases will remain the same, but what will vary is the design of experiments and test cases which are required to be derived to be ensuring that it is safer enough to handle. Like, few things I would definitely add in, like BMS is a key when we are talking about the current battery conditions, where we are talking about how it is ensure the safety, how it will ensure the abuse conditions, thermal abuse, mechanical abuse, electrical abuse conditions, how it is designed and derived. When we go to sodium-ion batteries, the BMS role becomes very different. If you go to aluminum batteries, which are primary batteries being discussed, there the requirements are entirely different. As well as we talk about supercapacitors, where the balancing and the requirements again differ. We can talk about also the hybrid energy storage systems, which are combination of two different energy sources. One could be normal lithium-ion or any other ion batteries, and the second could be supercapacitors, which has a high steep acceleration and deceleration rates. Finally, what we are talking about energy source, say for automotive, is to derive or to be suitable for the use cases of the automotive by itself. Something which is very, very effective in the storage environment could be very different than, or it could be engineered differently to suit for the automotive requirements. If you talk about automotive, it is steep acceleration, steep decelerations. So how effectively we can utilize its acceleration, fast acceleration, deceleration part, maybe the supercapacitors could be, ultracapacitors can be useful. There are some concepts where people are talked about supercapacitory. So actually myself, when we have worked about the combination of supercapacitor and battery, we have to have effective electronics in between, which takes about a bidirectional flow of DC-DC converter. However, there are people in the chemistry and innovation where people are talking about having supercapacitory together. So it's entirely one package only, which has a capacitor and battery combined. So there are innovations happening, and the test conditions and DOEs will change based on the technologies. Maybe the surrounding tools could be similar, and that's where the engineering efforts has to be sure, where we are covering the intent of it, not the words of it alone. Thank you.
Thank you very much for laying that out very clearly, and just shows the magnitude of work that you need to do to be able to cater to what everyone is making, and akin to saying hardware becoming commoditized and software being the differentiation. In your case, I think again, the testing equipment is the same, but the design of experiments and the way you design that is becoming different for every chemistry. So thanks for your comments on that. Coming to you, Mr. Kulkarni, and we heard the term LTO batteries just a few minutes ago, and we know about the very high charge rates that those batteries can support. Now we know whenever charging happens at such a high rate, it puts undue stress on the grid, right? And the quality of electricity then goes for a toss, whether it's the fluctuations happening, other things happening, and which is where then the role of, say, the charge point operator also comes in, say with the form of, ESS or supercapacitors or whatever. So if you could throw some light on that, because everyone is striving for faster charging rates in the future.
Thank you. I go with Madam, that each of these applications have to be, or the usage of the right chemistry has to be based on the application intended. In our case, where we are predominantly into the commercial vehicle electrification, we have now about 500 chargers, high capacity chargers, ranging between 240 kilowatt going up to 360 kilowatt. Both B2B and also on the highway charging. About 15,000 kilometers of Indian highways are now charged by ChargeZone. While we look at how do we make end-to-end meet what the vehicle needs at that point of time, what is the kind of current, what kind of discharge rate, what it can take. Can it take 0.5 C, can it take 1 C, or can it go even up to higher thing? On the other hand, we also have typical use cases. Last month we have deployed 2 electric buses in Bangalore airport. The duty cycle is about 20 to 22 hours in a day. The bus has to continuously run. And for them, every minute of bus running is a cost. So they have to no way afford to leave it for charging for 2 hours or 3 hours. So there the use case requirement was 10 minutes, 12 minutes, it has to be charged to 100 kilowatt. And there we could deploy the LTO batteries. So I think fully functional LTO batteries are deployed there. 100 kilowatt gets charged in about 12 minutes, 360 kilowatt charger perfectly working. It also fulfills the safety requirement in airports. Those regulations were of the highest order. So I think from an user industry point of view, it's worthwhile to say whichever chemistry you want to adopt, it has to justify the end use. Yeah? But all technologies will have to move from cradle to grave. Yeah? And I think the newer technology, whether it is aluminum air, zinc air, sodium air, they are in some phase of evolution. It needs time. Yeah? We should not end up with making some statements, some corner officers made $100 per kilowatt hour of LFP or a lithium-ion. And I don't think anybody would in this room vouch for that kind of a number for next 5 years. Yeah, but the business cases are made on the lithium-ion price will become 100, 125. A lot of companies have come up. At least personally, I have not seen those numbers happening. So I think before we make the mistake, I see a huge scope for what we can do on the current chemistries. Be it NMC, we have seen the energy density is moving from maybe 150 watt per kilogram going up to now 300, 350. Today, I think we also saw there are some demonstrations talking about 500 watts. LTO today, I was using the first set of pack was 95 watt per kg, and today the next batch which we have got higher capacity is talking about 150. So I am able to reduce the weight of the pack there. Similarly, in terms of pack making, one is the cell making. I think India will need some more time. That the significant quantity of cells are made in India. Yeah? But before we go to the cell made in India, which contributes maybe in the total cost of the pack about 35%. So it's important from a government point of view, as a Atmanirbhar point of view, you have to make that in India. But while the companies will invest, they need a maturity cycle. There is a big scope of making the pack become leaner, pack become lighter, and pack become efficient. So from cell to module, module to pack, yeah. We used one pack, 100 kilowatt, it was 1 ton. And last year we used another pack, 100 kilowatt at 680 kgs. So 320 kgs of reduction in weight could happen because of smart way of packaging your components. So I think our request to the industry is to look at what are the most optimum ways of placing your cells in a safe way, package them in the right fashion, built in the electronics and BMS which is smart enough, use the right chemistry which can accommodate the right kind of a charge, and thereby I think we can accelerate the whole adoption of energy storage. Of course, the new technologies can always fit in very well, in my opinion, in the storage areas where you don't have constraint of packaging, weight or volume. So the new tech batteries can go in first in the energy storage area before they come to the automotive.
Sure. Thank you, Mr. Kulkarni, for those comments. I think finally and very importantly, coming to you, Mr. Yajnik, because really you are integrating that battery with the powertrain, and that's how whatever it has in it goes to the wheels, right? So we are seeing this whole trend around not just increase in energy density, but also power density as the peak power of batteries increasing. Earlier, there used to be a lot of consideration to powertrain to kind of have a flat, current curve out there so that too much strain is not placed on the batteries. But now with these innovations happening, how are you keeping up on the powertrain side so as to be able to extract the maximum out of these batteries, or even newer propulsion technologies that are coming into the vehicle?
Thank you. First, you've left me 1 minute 54 seconds to speak about all this, but I'll try. Who are we and what do we do? Okay, Electra EV started very early with electrifying, real experiments, like you spoke about design of experiments, real experiments using mostly physical means of testing, trying out and improving battery packs on the Nano, through which we went into the journey of electrifying, the Tigor, and then now we've launched ACV. We've got more than 10,000 vehicles now that have either been manufactured and are already on the roads or soon to come on the roads. There's a lot we are seeing that's happening in India. See, first and foremost, we just don't take, we are not a neutral battery technology company that is looking at a neutral battery technology. We're looking at a neutral technology for the entire powertrain. Our focus is on energy efficiency as batteries integrate with the motor, your entire power electronics, and for the use case that you are building. In many cases in India, we're actually having to reduce the energy density because it doesn't meet the business case, right? We are actually having to go from a 22, 23, 24 kilowatt hour battery pack down to 19 because the last mile use case doesn't need it at all. On the other hand, when we go to the West, as we go to Germany, because we are now going from India now to see how we can contribute to making full powertrains in Germany. There is coexistence of, for example, hydrogen battery technology or hydrogen ICE, as we call it in India, for the fact that we want to use the same engine. There is a lot of optimization needed between what you have in the battery, your motor, your controller. So various controllers have to interplay with each other, and what we call in engineering, the web of conflict has to be resolved to come out with the right, efficient model. And in India, a lot of things are driven by cost, right? So your entire, so one, we speak about higher energy density, and I'll come to the power density, time's up, but I'll take a minute more.
I think the clock's moved faster than how much we've
Perhaps.
allocated, so yeah.
It moves faster than the interest that we have in this topic. But I think somebody spoke about supercapacitors. There is an architecture that we have built which incorporates normal lithium-ion architecture along with supercapacitors needed for power surges as we go to larger lorries and MNHCV applications. And that is all going to be controlled through, obviously, the BMS, but then cost comes in. You know, cost factor is very, very important. Finally, we've got to do that trade-off and see what's real for which real market. But we are not only working on lithium-ion, and rightly said, you know, the whole evolution of AIS 048 was for the earlier batteries, now the 156, which is at par with UL 2271. We've got to really juxtapose all different kinds of technologies with the motor controller, and all the electronics that go with it, and then see what is the efficiency level and at what cost. These are the two factors. Obviously, long life, durability, safety, all those are tick marks that you have to do. But more importantly in India is cost drivers and what's going to last durable. We were just in a conversation with my colleague this morning when we were speaking about applications that is in remote villages for off-highway, where they said that, you know, those use cases have not been built at all. So how will you be able to optimize your BMS? We said, well, we have to work with the motor controller guys online, working together, shoulder to shoulder, which is where the importance of integrating your electronics that comes from the MCU, working with the VCU and your BMS together. So the juxtaposition of all them working in tandem, in orchestra, is critical.
Understand. Yeah, definitely, and very, very pertinent points there. I think just so that we have sort of a closing thing to it also, maybe if you could also talk briefly, starting with you and then the others, the very important role of sort of collaboration in also making sure that some of these new waves of energy storage technologies can actually see the light of the day and be also most useful for mobility in future.
So I think just to summarize, it's very clear that we need to have this coexistence. We saw that. And very unique what Ujjwala ma'am also talked about. This I've seen in this industry because I'm new, I could observe that the DOE plays a very critical role. It's a very fast changing industry. I'm talking about battery only now. And I have seen our designers really struggle. We don't have that library which I used to have in my other 25 years, what I saw. There's no library where you just pick and make a safest and the best. You really need to wait. And then sometimes customer is like, oh, you are not giving any final guarantee or not giving, it will not work here. So that needs some kind of an open source collaboration that can we start sharing, and the role of ARAI, ICAT, I think is immense, but we are not yet there. Believe me, if I have to really take my designers to a institute and they say, okay, let's collaborate and something will come out in 3 months or 4 months, and also the life cycle tests are so longer, it's actually a challenge. So this needs a different level of collaboration. I must appeal again there. And this first part, which I told earlier, is in the circular economy, because it's like the cartridge. Battery has to have circularity. It is not something which will last for life. There will be, and we can't postpone it. Can we now start talking about that? How are we going to have this aftermarket? In our country, the aftermarket is still unregulated. It's still in the hand of unorganized people. And it's important that we get that piece now. Even Siam has to work with ACMA because we have genuine OE and then you have the non-genuine everybody. That doesn't work here. Every small player, big player in the EV sector at least has to come together. So that collaboration is that partnership of equals, even if the guy is small, even if his scope is smaller, I think we have to bring it. It's a different way of working. I have not seen in past, but this two angle I see has to be there.
Sure. Thank you. Thank you for those questions, Mr. Pandey. Yes, Mr. Yajnik.
I want to challenge everybody here. I think India is at a tipping point where we can lead by building applications that are relevant for the world, not only in India, but everywhere else. Collaboration is quintessential. I mean, there are Western and Chinese companies and other companies around the world that have worked on specific technologies, but they are typically myopic in their application. If you look at agri applications, if you look at last mile application, if you look at a lot of these small car applications, there is a lot of scope to innovate and to come out with products, technologies, powertrain and otherwise that can lead and really dominate in the world space.
Sure. Yeah, thank you. Thank you for those comments. Yeah, very, very, very important points there. Yeah. Yes, Mr. Bala.
Yeah, basically the first one I would request all of you, don't go after what you read from the Western technical publications. Okay, it doesn't make any sense for our own need. The day we start thinking for our own need, we would capture a big market, we will create big market, we will all grow. Okay, today, so if I say lead acid battery vehicle we can sell less than 30,000 rupees, nobody want to accept it. There are problems with lead acid, it can be solved, lead acid can be revived. There is a need to do that, like, rather everybody want to have a fame too, which doesn't make any sense at all. Okay, so if we could look at our own need, like, city travel, if you are traveling less than 40 kilometers, you don't need a lithium battery vehicle at all. So only thing with lead acid battery, there's a problem called sulfation. Sulfation means you cannot charge after you use for a while, immediately after you use for a while. You cannot totally discharge the battery and leave it more than 5 hours. This is the biggest cause of problem why lead acid battery doesn't last in a vehicle. And people, if they are educated, and this could make, because however it's recycling, there will be a lot of unorganized sector, but we have a lot of players in lead acid, dominant players, and the entire ecosystem is there, we could use. While we try to tell that there are a lot of discouraging factors against things like this. If you look at even today, China is the biggest electric vehicle in the whole world, and especially in two-wheelers. Even today, 50% or more of their two-wheelers run on lead acid. But we Indians, we don't want lead acid. And we don't even think looking at, because we all will tell, Indians are price-sensitive market, but we never look for a solution which will address price sensitivity. So the thing is, start looking, it is time to look our own solutions, our own standards, our own vehicles and equipments, our own. That day only things will change, which also means we may have to create our own test equipments, you have to create our own manufacturing equipments. That is when you control the market. That is when you grow the market. So to all of you here, so we all come a long way. Okay? When I started my career, pretty much I wanted to have what I call reference design to copy. That's how I started my career. Okay? And pretty much my generation was like that. Literally, we have thought the thinking only white guy has a brain, we don't have a brain, we have to copy him. That's how we started our career. Okay? But as we progress, as we went, now we know that we are better than the damn guys. Anybody. Okay? I tell you, you cannot have, Indians cannot be surprised at all with what they can create. And that is the, there's the word jugaad. You look at the jugaads Indian can create. Actually, jugaad is not a simple thing, let me tell you. A perfectly working jugaad is the best master engineering piece. Perfectly working jugaad. Because without basics, you cannot create anything to work. Without basic physics, you cannot create anything to work properly, even if it is jugaad. The only difference is jugaad would not have the consistency or reliability. It needs an additional jugaad engineering to continue. Okay, it's just a matter of additional jugaad engineering to continue. So the basic itself is creative, innovative, engineering-based, and made to work. Look at all the jugaads what we have created. This is a very unique quality we as Indians have, and we should all be proud of and should be able to monetize that proudness. This is what I request from all of you. If you want to say, like, we want to be the next superpower, we want to be the next market capture, unless you create something unique, which you only create, you cannot do any of those things. Trust me, this is true. And this is not with us, it's with all of us. Okay? Until we get into this and say, develop a solution which is specific for our country, which is very unique, and which we focus and which we differentiate. This is exactly what the Chinese are doing. The Chinese ensured Western world doesn't succeed in electric vehicle market just by doing their own standard. Their own standard. Whatever they've created is their own standard. Same damn thing we could create for our own country. And if we create for our own country, we will sell to the following country. I will list down for you. Entire Southeast Asian country except Singapore and Malaysia. You take it like, Myanmar, Laos, Cambodia, Vietnam, Thailand, Indonesia, Philippines, all we can export. Entire South American countries we can export. Entire African countries we can export. And you believe there is $4 billion people is in the countries which are quote unquote developing countries, including us. If we can do something, entire developing country, which will be the future market, we Indians will win, and we can achieve whatever, superpower, money power, economic power, whatever power, that entire base is there, please utilize. Not only in EV. EV happens to be the, glamour girl of the today. Okay? And it can be varying. Another, tomorrow you will find one more, beautiful girl, things will change. Today this girl is the best actress for some more time. Okay? This is my humble request to all of you.
Sure. Thank you, Mr. Bala. I think in ICE also we have a lot of such examples. Yeah. Mr. Kulkarni, your views.
I would only say that what was the range anxiety and then triggering the larger size of the battery, a couple of years back, everybody was asking, what is the size of the battery? If you say on a two-wheeler, 2 kilowatt, then they say 4 kilowatt. Okay, and that's how the subsidy is also capped at 4 kilowatt. But I think with the infrastructure picking up, at least in most of the sectors, quadrilateral, so the need for unnecessary extra size of battery in your vehicle is not called for. Of course, it has to do the balancing between what the powertrain needs. I think I agree with Samir. It has to be application specific. If the motor needs particular current and current voltage, both in terms of acceleration, that should be the limiting factor for the battery size. Rest of the things can be taken care by the charging infrastructure.
Very true. Thank you. Madam, your views.
I will be quite quick. I agree to most of the points. So I'll make only one separate point. When we talked about circularity, I think reduce, recycle, and reuse is the key when it comes to batteries. It has to be looked into very seriously. When we say recycle, how the raw material or the crush material can be reused by making the new batteries is very important. Second, when we talk about energy independence, the local materials and availability of materials is a key part of it. It will also add to the circularity because the transportation add to the entire cost of life cycle analysis. And the third is whatever the chemistry or whatever technologies that you use in, look into the how the established infrastructure can be reused, which is very key. Again, this will add to the sustainability part of it. And I strongly believe that together we can really do it. And collaboration is a key for the success for everyone. Thank you.
Thank you. Thank you very much. Thank you all. Yes, Mr. Pandey.
It's very compelling actually when this topic came regarding why we are not asking this question that we can use lead acid for the lower strata and why only lithium and now sodium. I think somewhere the Western media and I think in most of the conversation, this question also is not asked. So my request will be to you, Ashim, that take this also in a comprehensive approach when you are asking questions, that today the application, and that's why the DOE of why we are leaving that in the part of the complete choices. That choice still exists. Lakhs of your e-rickshaw is running only on lead acid, not on lithium-ion. So let's keep this also as part of the complete value chain. And if 30,000 we can really produce a two-wheeler, why we are not going there? So this discussion should be part of the EV discussion, not writing it off that it's gone.
Sure, definitely, point taken. And I think all of us go much wiser about the energy storage technologies of tomorrow, thanks to all of you. I enjoyed moderating this as much as I am sure you all enjoyed listening to it. So thank you all very much.